But we have the line of this was part D. Yeah, so let's have before we look at the resultant moment, let me just give you a scenario whereby we have a force acting in that direction. There is a force acting in this direction, and then there is a pivot somewhere here. This is where the pivot is, and then we are told that this is what, 30 degrees. So the angle between the line of action of the force, and of course the force is given as 4 newtons, then you are asked to work out the moment due to this force about P. So as I told you, just take your set square, slide it along the line of action of the force. Just slide it, just put your set square like this, then slide it along the line of action like that, and then there is a point where this edge here is going to meet P. This edge is going to meet P. So that, which point is that? This point, let me just move it a little bit, so it will be there. So I can now draw my line like that from this point. Yeah, so this is now the perpendicular distance. This distance here is the perpendicular distance from the line of action. So if you know this distance here, you can now say force times perpendicular distance, and this is going to be d sine theta. And something we have to remember, that distance from here to here was provided, and that distance was provided as 5 meters. So if we are working out the moment due to this force, we're going to say moment is equals to force times d sine theta, whereby our d is 5, so this is going to be 4 times 5 sine of 30. Then we are going to put this into the calculator so that we can be able to 4 times 5 sine 30, and if you work it out, you're going to get 10 Newton meter. Now 10 Newton meter is the correct answer for this particular case.